Hello everyone. I wish to conclude the discussion on water governor today by solving a couple of problems. Before I proceed with the discussion on solving problems, I would like to just revise what I have done in my couple of hours. This diagram is familiar with you. I have taken a very general problem. So I assume that the upper arm is pivoted at a distance from the axis of the rotation of the spindle, and similarly the lower arm also is hinged not on the axis, away from the axis, and in general or in particular problems this RCU, RCL may be 0. In that case they are hinged on the axis. That also is covered by taking them some value. So this upper arm, lower arm, and this is RCU, this is RCL, and mass of each ball and the mass of the sleeve, these are all constant. These are all the values which do not change with the position of sleeve. But some things like the radius of rotation of the ball, that will change with the position of the sleeve, and this alpha will change with the position of sleeve, and alpha will change, beta will change, and the speed omega also will change depending upon the position of the sleeve. Okay, so this right now whatever I have done, I assume that this is the sleeve now is not at the lowest position or not at the topmost position, it is in between, and therefore I have taken all these suffixes, these values r, etc., omega. I have taken alpha and beta. So in general, if the sleeve is at the lowest position, then those things alpha minimum, beta minimum, r minimum, h minimum, omega minimum I will take. And similarly, if the sleeve is at the topmost position, I shall call them as r max, omega max, h max, alpha max, beta max, etc. So before I proceed, just a relationship here. Sin alpha, for example, if I make use of this triangle, sin alpha is equal to this value. This value is nothing but radius minus this value, that is RCU, r minus RCU divided by LU into sin alpha. Similarly, sin beta is equal to a similar relationship. This value is nothing but r minus this value, RCL divided by LL. And I also have, if I extend the upper arm with the intersection of till it intersects the spindle axis, and this distance, as you all know, that is height of the governor, and that height of the governor can be obtained. That tan alpha is equal to r divided by h. And we also have derived certain expressions, and the first one being the equilibrium speed, and this without taking friction. So with Ff, the friction force is equal to 0. If you don't take friction force into account, then the speed relationship, this is an expression. And if you take friction force into account, and when the sleeve tends to go down, and that time the speed becomes omega dash, and omega dash square is given by this. And similarly, omega double dash square is given by this. This is when the sleeve tends to go up. When the sleeve tends to go up, that time the friction force is in the downward direction, the weight also is in the downward direction, that time the speed is this. And omega dash is less than omega, and omega double dash is greater than omega. And between omega dash and omega double dash, the governor doesn't work, or in other words, the spindle doesn't move, and we say that the governor is insensitive in that range of speed between omega dash and omega double dash. This is true in every position of the sleeve. So at the lowest position, I shall have omega minimum. This G will remain same. This H becomes H minimum. These are all constant. So then K becomes K minimum. Then this omega dash minimum square, this H minimum, this is K minimum, and omega double dash square, this is H minimum, and this is K minimum. Like that, accordingly they change. And similarly, for the topmost position, this omega becomes omega max square. This is g upon h max, then 1 plus k max. All other things will remain same, they don't change. Then similarly omega max dash square, 1 upon h max, okay, and k max. So omega max double dash square. So again this becomes h max and k max. So what is h? So tan alpha max is equal to r max upon h max, like that. Okay, for maximum position or minimum position, these accordingly will change. Sin alpha minimum is equal to r minimum minus r cu divided by lu, like sin beta minimum, r minimum, like that. So this for minimum position and maximum position. So these are the changes. Anyway, whatever I have explained now, I would like to apply it in a particular problem and would like to solve it. There is a problem in the examination question paper. This is 10ME54. The scheme is 10 scheme, and December 2012 there is a problem on photo governor and it carries 16 marks. Out of 20 marks question, you have a problem on for 16 marks. The problem has been already given to you, and I also would like to read along with you. So I will read it loudly for you, and I wish you also read along with me. Okay? So the problem goes like this. So first I shall read, and then I shall come back and read it again, and in the second reading I shall also write down what are the given things. In an engine governor of the prototype, the upper arms and lower arms are 200 mm and 250 mm respectively, and pivoted on the axis of rotation. So please, while reading itself, you try to understand what the meaning. The mass of the central load is 15 kg and the mass of each ball is 2 kg. And friction of the sleeve together with the resistance of the operating gear is equal to a load of 24 Newton at the sleeve. The limiting inclination of the upper arms, please remember, the limiting inclination of the upper arms to the vertical R, vertical means the axis R, 30 degrees and 40 degrees. Find, taking friction into account, range of speed of the governor. I hope you have understood. While reading itself, first reading itself, the problem is quite simple and straightforward. Now I shall read it again and write down. So in an engine governor, the prototype upper and lower arms are 200 mm and 250 mm. So here I shall straight away write it in meters, 0.2 meters. Sorry, this is the upper arm. The length of the upper and lower arms. Yes, upper arm is 0.2 meters and lower arm is 0.25 meters. Okay. Then both of them are pivoted on the axis of rotation. Therefore, RCU is also equal to RCL, and both of them are equal to 0. And mass of the central load, that is nothing but mass of the sleeve, this is equal to 15 kg, and mass of each ball, it is given as 2 kg. And the friction force, FFR, it is equivalent to 24 Newton. This is 24 Newton at the sleeve. The limiting inclination, please remember what do we mean by limiting inclination? This alpha value cannot go less than 30 degrees. What is the meaning of that? If alpha is 30 degrees, the sleeve is at its bottommost position. Therefore, this 30 degrees is alpha minimum. The angle alpha corresponding to the lowest position of the sling is 30 degrees. Alpha minimum is 30 degrees and alpha maximum is 40 degrees. These are the values of what is called as the limiting inclination of upper arm with the vertical. Okay, find taking friction into account the range of speed. The range of speed is nothing but what is the minimum speed of the governor to the maximum speed of the governor. So you go through all this. Okay, so I have this omega, omega dash, omega double dash. I have omega minimum dash, omega minimum double dash. I have omega maximum dash, omega maximum double dash. So among all this, what is the minimum speed? The minimum speed is omega minimum dash. Omega minimum dash is the least speed. And among all this, what is the maximum speed? The maximum speed is omega maximum. Is it omega maximum dash or omega max or omega max double dash? It is omega max double dash. So you are asked to find out this speed and subtract omega max double dash minus omega minimum dash, and that is the range of speed taking friction into account. So ultimately what we need to find out is this and this. Okay, so first I shall find out what is called as find omega minimum dash. Omega minimum dash. This I will find out. So I have to make use of this expression. So I shall write down the expression omega minimum dash square is equal to 1 upon h minimum multiplied by this mb into g plus ms into g minus fr divided by 2 into 1 plus k minimum divided by mb. Now go to this expression and find out what are the things you know. So I know mb, g, ms, g, mb, ffr I know. So I need to find out only h minimum and k minimum. H minimum and k minimum. So for that I shall find out what is called as r minimum first. R minimum. Okay. So I make use of this r minimum. Okay. So what is r minimum? So I can make use of this. I know alpha. Sin alpha is known. Lu is known. RCu is 0. So you can make use of this, and therefore, so R minimum can be found out from this. Sin alpha minimum is equal to R minimum minus RCu is 0 divided by Lu. So making use of this, find out what is called as alpha minimum. How can you tell me what is the value of alpha minimum? Or you can substitute and then R minimum, or otherwise R minimum is equal to Lu. This is nothing but 0.2. Lu is 0.2 into sin of alpha minimum is 30 degrees. 0.1 meter. So this is R minimum. Okay, why R minimum is required? Because I want to find out what is called as H minimum. Okay, so making use of this tan alpha minimum. Tan alpha minimum. Tan alpha minimum is equal to R minimum. R minimum is nothing but 0.1. Already we have found out 0.1 divided by H minimum. So from this we find out what is called as H minimum. H minimum is equal to 0.1 divided by tan 30. This is 0.1 divided by tan 30. How much?
0.173.
0.173 meters. 0.173 meters. This is a H minimum. So this is what. So now I also need K minimum. K minimum is what? K minimum is tan beta minimum divided by tan alpha minimum. So this is how you can find out what is called as K minimum. So therefore first I need to find out what is beta minimum. So for that I make use of the expression sin beta minimum. Sin beta minimum is equal to R, that is nothing but R minimum, that is nothing but 0.1 minus R here, that is 0, divided by the lower R, that is equal to 0.25. So this value is 0.1. 0.1 divided by 0.25, and from this you find out what is called as beta minimum. This is so many degrees. Sin inverse of 0.1 divided by 0.25.
23.57.
43. 23.57 degrees. Okay, this is beta minimum. So tan beta minimum divided by tan alpha minimum. This is equal to K minimum. So find out what is K minimum. Okay, so now all the values K minimum is known, FR is known, that is 24 Newton. 24 Newton, that's yes, 24 Newton. This is known. G value is 9.8. MS is 15 kg. So MB is known. All the values is known, and therefore you can easily find out omega dash square and take the square root. You come to know what is called as omega dash. And if you know omega dash, you can keep it. Omega dash is so many, omega dash minimum is so many radians per second, and you can easily convert it into RPM also. You can easily convert it into the RPM. That will give you what is M minimum dash. So this is how you can find out this value. Omega minimum dash can be found out so easily. And exactly on the same lines, omega maximum double dash. So what will be the change in the formula? So I shall make use of my, I shall rub some portion and
K minimum 0.755.
K minimum is not 1.32, it is
755.
0.755. Okay, whatever the value, okay, you can check the calculation. If this is wrong, then you can again correct it. No, absolutely no problem. And only these two, K minimum and H minimum, these are the only two unknowns, and rest all things are known. That is how you can find out omega minimum dash. Now, how to find out the second one, omega maximum double dash? This is second one, to find the omega maximum double dash. So what will be the formula? Omega maximum double dash square is equal to 1 upon H max into MB into G plus MS into G plus the friction force now divided by 2 into 1 plus K max, the whole thing divided by MB. So here also again there are only two unknowns, H max and K max. So you can easily find out making use of the sin alpha max. Now alpha is 40, alpha max is 40 degrees. Sin 40 degrees is equal to R max divided by 0.2. So knowing this you can easily find out. So R max can be calculated. I will give you so many meters. Then you can write down what is called as tan alpha max. that is nothing but tan 40 degrees is equal to R max, whatever the value you have got here, that divided by H max. So knowing this and this, you can easily find out what is called as H max can be found out. This also, this value is known now. Okay, again you can easily find out what is sin beta max. Sin beta max from using that is the R, nothing but R max, which you have already calculated, minus R here, that is 0, divided by L, that is 0.25. So you know this value, you know this value, this is the only unknown, and from that you can find out what is beta max. So many degrees. You know alpha max, the 40 degrees, and you know beta max, you have calculated, and therefore you can easily calculate what is K max. That is nothing but tan beta max divided by tan alpha max. You know K max, you know H max, and substitute here, and that is how you can easily find out omega max double dash. Okay, you are finding out square first and then take the square root, you will get omega max double dash, and that from that you can convert that speed in terms of RPM. That will give you what is N max double dash. So omega max double dash minus omega minimum dash, that will give you the range of speed in radians per second. Similarly, N max double dash minus N minimum dash, that will give you the range of speed in RPM. So this is how you can solve the problem. All the problems will be very, very similar on this line, because mostly will be of a substitution type. So I wish you to go through this, and I also wish you to go through the question paper problems, and maybe if you feel and if you want me to solve some more problems, I don't mind. But at the same time, you also have to put in efforts, and that is how you can understand. Okay, all the best.